So this is how I solve problem number 5 for homework 11. Step 1 is to make sure the problem is in general form, which it already is, so we can check that off. Step 2 is to write it in this form here of d squared minus 2d plus 1 of y is equal to x e to the x ln of x, which is our g of x. Step 3 is to find the homogeneous version, which is the same thing as above, except we're going to set it equal to 0. Step 4, we find our m's. So of course that's going to give us m squared minus 2m plus 1 is equal to 0. We can easily factor that to make it m minus 1 squared, or m minus 1 times m minus 1. So that is going to give us 2 m's. Both of them will equal 1. And that'll give us our fundamental solution with base h. And of course that's going to be e to the x, comma x e to the x, to account for both the ones. So now we can find our y of c, which is just a linear combination. So c1 e to the x plus c2 x e to the x. We're going to need that for later, so we're going to go ahead and box that out. Now, those steps were the same as for all the other problems in the previous homeworks. But now for step 5, that's where we're going to use the Wronskian method. So to do the Wronskian method, it's all matrices. We have w equals y base 1, y base 1 prime, y sub 2, and y sub 2 prime. So of course our y sub 1 is this e to the x here, and our y sub 2 is this x e to the x here. So now we can substitute those in, and we're going to get e to the x. The derivative of that is also e to the x e to the x, and then some product rule, you get x, or e to the x plus x e to the x. We're going to find our w2, or that's going to be w1 first. That's another matrix, and you're always going to put 0 up here, and then it's going to be x e to the x for this x e to the x here, and then over here is our g of x, and g of x is this all the way up here in the original problem. Whatever is going to be to the right of the equal sign is your g of x. So we can go ahead and write our g of x down here. That's going to give us x e to the x ln of x, and then here we have e to the x plus x e to the x, and that is our y sub 2 prime here. So we transfer those over. And now our w2 is another matrix, and that's going to equal e to the x and e to the x. For the e to the x's we have here, and then we have our 0 and our g of x, which stays the same, and that is x e to the x natural log of x. The next step, which I'm going to do over here, is to write the determinants. So to find the determinants, you multiply these and subtract the multiply, or the product of those. So over here, for our w, we're going to have e to the 2x plus x e to the 2x minus x e to the 2x, and that is equal to e to the 2x. So that is our determinant for the first w. And now our determinant for w1 over here is 0, because we have the multiply 0 times this equals 0. So 0 minus x squared e to the 2x natural log of x, and here that equals negative x squared e to the 2x natural log of x. And for w3, I'll write it here. We have x e to the 2x natural log of x minus 0, and that equals x e to the 2x natural log of x. So we have our determinant for w, our determinant for w1, and our determinant for w2. So now u1 prime is equal to w1 over w. So w1 is right here, the determinant over w. So we're going to go ahead and write that. That is going to give us negative x squared e to the 2x natural log of x over e to the 2x, and these will cancel out. And now I'm going to find u2 prime, which is w2 over w. So now if we plug those in, we get x e to the 2x natural log of x all over e to the 2x. And these will cancel out. So now we're going to have to find the integration of here and the integration of here in order to find what simply u sub 1 equals and u sub 2 equals. Okay. So u sub 1 equals the integration of negative x squared natural log of x dx and you can pause the video, do your integration by parts, and you should get an answer of x cubed over 9 minus 1 over 3 x cubed natural log of x. And for u base 2, that is going to equal the integration of x natural log of x dx. You can do integration by parts again, and you should get 1/2 x squared natural log of x plus negative x squared over 4. And y of p is going to equal u1 y1 plus u2 y2. So now when we plug in, we're going to get x cubed over 9 plus negative x cubed over 3 natural log of x multiplied by our y1, which was e to the x, plus 1/2 x squared natural log of x minus x squared over 4 times our y2, which was x e to the x. If we simplify that to make it look a little nicer, we get e to the x over 9 x cubed minus 3x cubed natural log of x plus x e to the x over 4 2x squared natural log of x minus x squared. So all of this is our y of p. Last step, general solution is equal to y equals yc plus yp. Now we'll just plug in. We found that our yc earlier is equal to, I'll just go ahead and write the final answer. Yc is equal to c1 e to the x plus c2 x e to the x. Now our yp we just found is e to the x over 9 x cubed minus 3x cubed plus x e to the x over 4 2x squared ln of x minus x squared. So here is our final answer, and this is equal to our y of c, and this here is our y of p. That's how I solved problem number 5 to homework 11. Thank you.